for this example, you can see whenever I ask you to find the middle of the linked list, I just ask you what is the middle of the linked list, which means you have to point here your linked list head and you will be good to go. So you can see if you point here, then you can just give me this list, which is 3, 4, 5. And for here in this example, the middle of the linked list is 4, 5, 6, and that's the answer. Now, one very basic way is you go and do one iteration and find the length of the linked list. Other ways, okay, and for sure, if you go and find the length of the linked list in one go, then in the next step, you know that in how many, which means if you have find the n in one go, in the next go, you will find n by 2 and then you will stop at that point. So that will be 2n operation. But you can do it in O of n by itself doing a slow and fast pointer approach. What it means by that is that for sure, you know that the entire linked list is of length n. You want to reach the half length, which means I can easily say, okay, if one pointer can reach the end and if another pointer is going by the half speed, so the other pointer will be half at a distance of half instead of the other pointer. So that is called as a slow and fast pointer approach. What it does is in the very beginning, you put both the pointers slow and fast at the initial head. So here you have the head and both the pointers you place it here. Now slow pointer you will move by 1 step and fast you will move by 2 steps. Why? Because as soon as the fast reaches end, you will know the slow will be just exactly at the half, because you know speed is equals to distance upon time. If some distance is twice the speed, if some distance is twice, the speed will be twice. So I'm saying I'm moving my fast pointer with the twice speed, so he will cover the twice distance as that of slow pointer. And if this twice distance is actually n, so the distance of slow pointer covered will be n by 2. Cool. So that's the simple maths which we will use. So you will see fast will move 2 steps, slow will move 1 step. So slow moved 1 step, fast moved 2 steps. Now slow is here, fast is here. Again, I will let fast reach the end. So slow will reach, okay, 1 step, fast will again move 2 steps. So fast is here. Now fast has reached the end. Aryan, what do you mean by end? Aryan, are you saying that end is this point, which is end is after the linked list ends, or end you are seeing the end of the linked list? Frankly, I also don't know. I figured out that by saying, okay, can I move my fast 1 more step? Maybe I can, maybe I cannot. If I do a fast, which means I know the fast moves 2 steps. So I have to do a fast next, then next. So that fast moves 2 steps. When I do a fast next, it will be pointing to null. Null's next will give me null pointer exceptions. So I know one thing. I cannot do this point as soon as I have reached the end. So one thing is for sure. I cannot try this if I have reached the fast. So if my fast reach the end, which means I can say either my fast is null or my fast next is null. In any ways whatsoever, I have reached my super end. So that's what I can put as a condition for me. Now in this case, you can see your slow is exactly at the midpoint. So okay, great bro, your slow is at the mid. So you can simply say, bro, this is the middle, and you can return that. And you saw that you just simply iterated once in the linked list. And the same way again, in these kind of cases, please make sure that you consider both odd and even lengths, because here you are actually working or playing with the length of the linked list. Length is n by 2, like length is n and then you do n by 2. So that n by 2 can, because depending upon n is even or odd, your n by 2, you can just go into some other direction. So in these cases, whenever you're doing n by 2 and you're considered about that, so please make sure that you actually think of, okay, what if the length is odd, or if the length is even, if you're considered odd. So in this case, we considered n as 5, which is odd. Let's also try once for n as even. So we saw, okay, our slow and fast pointer, slow will move 1 step, fast will move 2 steps. Fast is here, slow is here. Still, I will let fast move. Slow is again this, and fast again move to end. So now my fast is here, slow is here. Again, you can see your fast moved. So that's the reason I just took both the conditions. If my fast is null or my fast next is null, in both the cases I can stop. So in this case, you can also see that my fast has reached the end, so my slow is pointing here, and that's the also middle of the linked list. So the code will look exactly simple, that you will simply have your slow at the head, you will have your fast at the head. Now as you saw in the code also, that while your fast, again I'm showing you the code, although I have explained that previously in the video also, while your fast is not equals to null or your fast next is not equals to null, then in both the cases you can actually move your fast. What you mean by fast is, okay, slow will move one step, which means slow will move slows next, and your fast will move again two steps. Your fast next, and you will keep on moving until your fast is there, and ultimately simply you can return your slow. That's your middle of the linked list, and that's your entire code, which will work in O of n time, which is just single pass. And the code exactly is also same. If I show you the code, your slow and fast pointer just both pointing to head, while your fast is not equal to null and your fast next is not equal to null, both moving your slow and fast pointer. Slow moves one step, fast move two steps, and ultimately return the slow, which is the middle of the linked list. Now you have seen one problem, which is very important problem, has been asked by so many companies. Now the second problem, again, this is all the backbone of today's problem. Now second problem is reverse the linked list. Both iterative and recursive phase I have covered in this specific video with another approach for it properly described. Reverse the linked list. Just for a recap, I will show you that what we did in this reverse the linked list. We have to reverse the linked list, which means linked list is 1, 2, 3, 4, and 5. Ultimately, we have to return, okay, 5, 4, 3, 2, 1, and once pointing to null. That we had to do. So ultimately, what we did was that, again, you can go and watch this entire video. Just write down video like problem name, which is like let's say Leetcode 206 by Aryan Mittal. You will get the entire video and you can watch the complete video. Now, but for a recap, what we did was we took a P, Q, and a R pointer, and then we just said, okay, Q's next will be P. But as we say, okay, Q's next will be P, we are actually forgetting Q's next, which is R. So I will keep track of R. I'll keep track of R and I'll say Q's next is P. So Q's next will be P, which is null. And thus this will go away. And as this is going away, so I have to keep track where R was. And then I will shift all of them. So I will shift, here will become my P, here will become my Q, and here will become my R. Again, Q's next will be my P. So again, just move, again, just shifting on P, Q, and R. Again, Q's next will be P. Again, as you can see, R is being generated because of Q's next first. Then after, I am just putting Q's next to P. Okay, Q's next is actually P. Again, the entire video, again, iterative is an easy way, recursive is a bit tricky way. Although iterative is the most efficient way for us because it takes over one space, but still, recursive has been asked by companies, so I'll highly recommend, please go and watch this video also. But by this, for this problem, I'm explaining what is actually required. Now, okay, RP is here, Q is here, and R is here. Ultimately, again, do Q's left is Q's next is P. Then again, move your P, Q, and R. P, Q, and R. Again, Q's, oh sorry, where it is gone? Okay, yeah, Q's next is P. Okay, Q's next is P. Again, move P, Q, and R. Okay, P, sorry, here it is P, here it is Q, here it is R. Like R will not be there because we have reached the end, because Q is null, so there is no next for Q. So there is no R also. Now we see that, okay, we have completed. So I'll just simply say while my Q is not equal to null, I'll simply keep on moving. So my loop will look like, because you remember my P was here in the beginning, my Q was at head. So while my Q is not equals to null, I'll simply keep on moving my P, Q, and R, and ultimately you can see my new head is actually a P. So I can say simply a list node pointer P. Again, P is nothing initially, as you can see, P is pointing to null and my Q is pointing to my head. And then you can see your temporary variable, which was R. So that is a temporary variable, which is, you can just simply say that you can make inside the loop also or outside also. My temporary variable R was nothing but Q's next. But that is possible only when you have a Q not equal to null. So now you did one thing, okay, bro, Q's next, I was pointing to my P. Q's next, as you remembered, wherever Q's next was there, I was pointing it to P. So if my P was here, my Q was here, I was pointing my Q's next to P. Only after I have assigned my R variable, because R was having Q's next. So as to not forget Q's next, I assign QR to Q's next, and then I assign Q's next to P, and then for sure move the pointers, which means P will become Q and Q will become R, and that's the only thing. And as you remember, in the ultimate end, okay, why it is not erasing? In the ultimate end, my P was here and my Q was here. So while as my Q has become end, as you can see, my Q has become null. So I can simply say my head is pointing to P. So I can simply return my P, and that is my head itself. So this is the entire code for reversing a linked list. That will again take O of n time and O of 1 space. The code is exactly same as we have discussed in the video also. Again, it's the most efficient. So I have used a prev current pointer. My P, as you can see, is my prev, and my Q is my current pointer. This current next is my R, as I showed you in the explanation also. So while my Q's next is actually P, I'll say that okay, P is equals to my Q and Q is equals to my R, and ultimately return my P. That is exactly what we have done. The time and space, time is O of n, space is O of n. Now comes on, okay, a bit variation. Again, that is the base which you should know, and for sure you should be knowing. Now, palindrome the linked list, it just simply asks you, bro, is a linked list a palindrome? If you know, palindrome is nothing but starting and ending should be same, which means this and this should be same. If I ask you, this and this should be same, which means that again, if you want to watch a specific part of the video, which means specific question, please go and see the timestamp of the video. Now, when I say palindrome, I want to compare the ends of the linked list, end of the list. Imagine this is an array. So if this would have been an array, I would have compared this pointer and this pointer. Then I will compare this and this. So you can see, technically, one very easy way is iterate on this linked list, put this linked list into an array. 1, 2, 2, 1, and then compare by using 2 pointers. That's the very easy way. But you see that you will use O of n space for iterating on converting it into an array and then iterating on it. You will use O of n space, but for sure interview will ask you not to use an extra space. Then you will have to do the logic whatsoever you have learned in linked list. What you learned in linked list is, okay, that I know that I have to compare this and this. Then I have to compare this pointer and this pointer. So which means I have to iterate iterating from the end for the right half. For the left half, I have to iterate in the starting. Okay, one word comes in half. So I have to bifurcate this linked list into half linked list. Okay, when I will, first operation is to bifurcate that linked list into half linked list. Okay, half linked list I have got, but that's the right half linked list, and the right half linked list I have to iterate in from the end of the linked list rather than from the start. So okay, first operation is getting the half of the linked list. Second operation is iterating from the end of the linked list rather than the start of the linked list, which means I cannot iterate like this. I have to iterate like this, which means I will have to reverse this right half of the linked list. Okay, reverse the right half. So I'll exactly do the same operations. I will firstly know what is the half of the linked list, and then after I have gotten the half of the linked list, I will reverse that right half by, firstly, it is very easy for me to know the half of the linked list by using the middle of the linked list operation. Then I will reverse the linked list because I know how to reverse the linked list in the most efficient manner. Then when I have reversed it, then I can simply, I know this is my head 1, this is my head 2, and I can simply iterate on both the head 1s and head 2. For example, if I take the example itself, I know this is my linked list. I have to compare and I check if it's a palindrome or not. First operation was to get the half of the linked list. Again, I'll use simple slow and fast pointer technique. So while my fast is not equal to null or my fast next is not equal to null, I'll simply keep on moving my fast. Okay, my slow will reach here now, and my fast, sorry, this is my slow and this is my fast. Again, your slow will move 1 step, your fast will move 2 steps. Now your fast has reached the end, and you also for sure know that this is your half of the linked list. Okay, first operation done. Now reverse this half of the linked list, which means ultimately I want to perform this, I want to get this operation. And ultimately you remember that when you reverse a linked list, you also have an operation that, if you had gotten this video, I have specifically mentioned that the half, that this half points to null. That is important, so as to know the list is completed. So I come on back, I know that this will actually start pointing to null. Okay, I have to convert and get this operation. Okay, let's keep it, and now let's reverse it. How I will reverse it? I know that this is the linked list which I have right now, and this needs to be this needs to be reversed. If it is A, B, C, this needs to become a C, B, and A. Now, if this needs to be reversed, I know that this is the current head of the linked list. So now, for this reversed part, the new head of the linked list is this pointing at this slow. Okay, which is, okay, Q for us, P is null, and R I can just simply make like this, and I can simply now reverse the linked list. Now, Q's next is pointing to P. P is null right now, null. null. So my A is next has become null. So A is next. Make sure this arrow is as it is. It is, let's say it is Z and let's say Y. So Y is next is still a A. I am saying A is next rather than this pointing to B. It is actually pointing to null now. Okay. I am doing exactly same as what we did in the reverse of the linked list. Now, okay, simply move your P, Q and R. Okay, P is here now, Q is here, and again, like leave fast. Now fast is not needed. R is here. Again, Q's next will be P. Okay, Q's next will be P. Okay, now again, move your P, Q and R. Okay, P is here, Q is here, and R is here. Now again, Q's next will be P. Okay, Q's next will be P. Okay, again, make your P, Q and R. Okay, P and Q. For sure, if Q is there, Q is not, so R will not be there. And now you have got the reverse of the linked list. Now your P is pointing to the head 2 of the linked list. So now if you know your existing head was pointing here, your new head is pointing to P, and you have also reversed the linked list. So I can simply say that my head 1 will be the head of the linked list and my head 2 will be my P. Now my head 1 is the head of the linked list, my head 2 is my P, and then I can simply now iterate from the end. I can simply iterate from the end itself, and I can simply keep on comparing both the linked list. How I will compare? Simply check. Okay, if head value is equal, if the head values are equal, simply move on. Simply move on. Now, okay, which means simply move on. Okay, if head values are equal, which means Z value and C value, if they are equal, simply move on. Now my head 1 will be here, head 2 will be here. Again, compare. If the values are same, simply move on. If at any point values are not same, simply return a false. Okay, values are same, simply move on. Head 1 and head 2. Oh, values are same, simply move on. Now when I say move on, what will happen is that both head 1 and head 2 are pointing to A, and A's next is null. So both will become a null. So for sure, I can simply put a condition while my head 1 is not equals to null and my head 2 is not equal to null, I can simply keep on comparing. But you remember, Aryan, what about the odd? What if the elements, Aryan, the elements are odd here? What if the elements are even? Then what? Okay, no worries. Let's again try to replicate the exact same thing. Firstly, I'll find the middle of the linked list, which means slow is here, fast is here. Now, slow will move one step. Okay, slow is moving one step. Fast will move two steps. So 1, 2. Fast will move 2 steps. Fast. Again, slow will move one step. Fast will move 2 steps. Okay, now I know this is the half of the linked list. I will reverse the linked list. So, okay, make a Q here, make a P which is pointing to null, and make a R. Now, okay, P is next. So, my Q's next will be nothing but P. So, P is nothing right now null. So, I can say this Q's next will be null right now. Okay, great. Now, shift all P, Q and R. Okay, P, Q and R. Again, Q's next will be P. Okay, Q's next will be P. Again, shift them. So, I'll shift them. And now, P, Q and R. Now Q's next will be P. Okay, Q is null. So for sure I can simply break down. Now I have got the reverse of the linked list. Now this is my head 2. This is my head 2. Sorry, head 2 is equals to P. And my head 1 is actually my head. Now simply compare head 1, head 2 values. Are they same? Yeah, if they are same, simply move on. So I can simply say this is right now my head 2, this is right now my head 1, and I can simply keep on comparing them. Okay, if they are same, move on. So my head 2 will be here and my head 1 will be here. Now, okay, if they are same, simply move on. When I say move on, head 2 will point to null, head 2 will go to null, and head 1 will actually come here. So I can simply, head 1 can simply come here. Now I can say simply, although I had compared head 1, head 2, like entire linked list was completed by so far by the previous step, entire linked list was completed comparing. So I can simply say that while this condition, while my both the heads are not null, or I can simply say while my head 2 is not null, still that is also absolutely correct. That simply first operation is getting the half, which means getting the slow. After getting the slow, I made my P, Q and R pointers, P and Q pointers specifically, and R pointers was just Q's next. Specifically, I made that, and then I iterated on the from super end and then compared. So exactly, if I repeat it, this is getting the slow and exactly same code. I got the slow and fast pointers. By this fact, I have so far gotten my slow is pointing here, or in the case of the linked list length is even, my slow is pointing here. When this is done, you remembered that this will be my Q wherever slow is pointing. P will be for sure null, and R, I can say for sure it is Q's next. So my P and Q are the most like primary thing. R, I can keep it inside also, which means list node pointer R, which is nothing but Q's next. Now I'll simply reverse this part of the linked list, which is the right half of the linked list. I'll simply reverse it. When I say reverse it, I simply mean that, okay, let's put an arrow here. So when I say I'll simply reverse it, I'll simply say that Q's next is equal to P and then change the signs. Now this is the reversing part of the linked list. When this is done, I know that now my linked list looks like this. Linked list looks like this. Now I'll simply have my head 1. Head 1 is pointing to the existing head. Head 1 is the existing head. Head 2 is the P. Because for the reverse linked list, you know that P will be the head. P will be the head of the reversed linked list. Now simply keep on comparing from both the ends. So while my head 1 is not equal to null and my head 2 is not equal to null, or you can also remove the entire this head 1 part and say while your head 2 is not equal to null, still that will work, because we saw with the explanation itself. Simply if both the heads are there, you can simply compare the head values, head 1 value and head 2 value. If they are not equal, return false, else keep on moving both the heads. Head 1 will move one step, head 2 will move one step. Head 1 will move one step, head 2 will move one step, and ultimately if for sure they are same, return a true in the ultimate end. That's how you solve the palindrome problem. And coming on to today's problem, which is the reorder list, it's also exactly same. If you see that it just says bro, it says you bro 1 4. Imagine these two as a separate linked list, which means 4 3 1 2. So imagine 1 2 as one linked list, 3 4 3 as next linked list. So you can simply say, Aryan, I gave you two linked lists. I gave you 1 2. I gave you 4 3. You have to merge these linked lists in alternate fashion, which means you will have your head 1 here and head 2 here. I'll say, okay, head 1, then head 2, then head 1, then head 2. Iterate like this, and that's the answer. You have to simply order, okay, head 1, head 2, head 1, head 2, head 1, head 2. So what you thought of, what is happening? Firstly, you actually bifurcated this linked list in half. Then you reversed the right half of the linked list so as to iterate from the end of the linked list, which we have been also doing above. And then you just simply did what? You just simply did the merging of that linked list. So again, for this example also, I will simply bifurcate that linked list. Again, remember one fact. Aryan, this is how the fashion half is looking like. But if you go and see how our half is looking like, our half will look like, if I just take this example, so our half look like, okay, Z, Y, and then A is pointing to null. If you see Z, Y, A is pointing to null, and then C, B, and A is pointing to null. This is how our halves, which we have done, are looking like. People get confused when they don't make the diagram of the linked list, that okay, how their halves were looking like. So remember, this is how your half was looking like. Your Y is still pointing to A, but your A is pointing to null. That you had achieved by doing the reverse of the linked list of the right half. But remember, your Y is still pointing to A. So this is never broken. Remember that fact, because this is what we have seen, what our code is actually doing. So this is what you have to know, that okay, what code you are writing versus what your mind is actually thinking. Because your mind will actually skip that thing, but in your code your element is having the 3 but it's pointing to null. That is what is happening. But no worries, we will see everything. But yeah, this is what is happening. And same way for, let's say, if the linked list would have been, I will have, let's say, bifurcated that, let's say here or maybe here, anywhere. But what is happening is 1 and then 5, 1 and then 5, 2 and then 4, 2 and then 4, and then ultimately 3. Now let's see how this is actually being happening. So again, we will take, let's say, 1 2 3 and 4. Okay, let's erase this. It is exactly same as what we have seen above also. 1 2 3 and 4. I'm just doing a triangle of the same thing again and again. So it is slow, it is fast. Firstly, I'll reach the middle of the linked list. How? Okay, so slow will move one step, fast will move 2 steps. Again, slow will move one step, slow will move one step, fast will move 2 steps. Okay, fast has reached here. Now I have reached the half of the linked list. Now simply reverse the linked list. Okay, my Q will point into my slow, P will point into my null, and R will be the Q's next. Now Q's next is null. Okay, Q's next is null. Great. Now move your P, Q, and R. P, Q, and your R. Again, Q's next is P. Okay, great. Simply move on. Your P, Q, and R will not be there because Q is actually null. Now your P is pointing to my head. and my initial head is pointing to this. So I can say this is my head 1, this is my head 2. Now simply keep on merging them. Okay, I'll simply say, okay, while Aryan, how I should stop, what while loop to apply? No worries, bro, we will see that. Firstly, logically, let's see that until what point they will actually merge. Okay, I will simply say that, okay, head 1, I will say, then next, head 1's, next I will put head 2. So I'm just actually doing, okay, head 1's, next I'm putting a head 2. But I should also keep track of what was the next of head 1. So because I know my head 1 should move like this next, technically, but head 1's next I'm putting to head 2. So one thing I realized that, okay, I should keep track of what is the next of head 1. So I just say, okay, list node pointer, let's temporary pointer. Let's say name it as a head 1's next. Head 1's next. I have grabbed that next pointer of head 1. Now I can simply say that head 1's next will be head 2. Now I know that very luckily that head 1 will be now temp, because head 1's duty is done. Head 1 will now be pointing to here. But you also saw that head 2's next will be your head 1, which is the new head 1. So I can simply say, okay, head 2's next will be the head 1. But Aryan, you also have to move your head 2 next here, right? But you forgot your where head 2 next, because you have pointed your head 2 next to 4. But you forgot what was 3, which was the actual head 2 next. Yeah, bro. So I'll just simply say that, okay, my temp variable is still useful because I have assigned head 1. So my temp is still useful. I can simply say, okay, my temp will actually be pointing to my head 2 next. So as to not forget what was the actual head 2 next. Now, my head 2 next is pointing to head 1. And then I can simply move my head 2 also. Move my head 2 also. Okay, now my head 2 is temp. Now, okay, now repeat the same process, which means compare head 2 next will be 3. 3's next will be post of head 2. We will see what is happening. But Aryan, 1's next is 4. 4's next is 2. Again, this is what you had done by this simple loop. And you can easily see that 2's next is 3, 3's next is null. So technically your answer is solved. Don't repeat the loop. So Aryan, are you saying I'll do a if condition for this? I will say not if condition, but you can have a while condition, because the loop can be very big, because the linked list right now is of length 4. What if it is of length 6? Then you will simply say, here is my head 1, here is my head 2. So technically you will have to apply a while loop, which is while your list is there, you will simply keep on moving. But what is the condition when I have to stop the while loop? So I realized my head 1 is pointing here, head 2 is pointing here, and I had to stop. What is so unique about this condition? My head 2's next is null. Oh, I can simply, as you remember previously also, that your head 2 was sufficient. But I'm saying here in this case, my head 2 next is null. If that is equal, okay, if my head 2's next, if that is null, then I can simply keep on moving. Sorry, until it is not equal to null, which means it is not equal to null, it is not equal to null PTR. I'll simply keep on moving. As soon as it becomes equal to null, okay, I have to stop. Because you can see once 4, like 1, 4, 2, and 2's next is by default 3, 3's next is 4. Like 3's next is null. So I have got my answer. So that's great. That's great. But okay, I have been hiding this entire thing. Was I hiding other things also in the code? No worries. So this is what we had done. Now Aryan, this seems good, but will it follow for the other cases also? Let's see. No worries. So we had 1, let's say 2. Okay, let's simply repeat the exact same dry run. This, and this. Now again, we remembered first is slow and fast pointers, both pointing to head. Now my slow will move 1 step, fast will move 2 step. Okay, fast is here. Now my slow moves 1 step, fast will move 2 step. Okay, fast is here. Fast has reached the end. So I'll say this is the part I have to reverse. Again, my Q will be pointing at the location of slow, P will be pointing to my null, and R will be my Q's next. Okay, great. Now P's next will be Q. So Q's next will be P. So this will be pointing to null. Now simply move everyone. Okay, P, Q, and R. Again, for the folks who know why R is there, below R is just to keep track where Q should move next. Now Q's next is P. Again, for this you can watch the previous video, which I have showed you above also. Now okay, my P is here, my Q is here, and for sure my R is here. Now my Q's next is this. Now again, move your P is here and your Q is here. Now Q's become null, so you can simply stop. You have now reversed your linked list. Now simply merge them. This is your head 1, this is your head 2, which is pointing to P. Now simply head 1, head 2. Head 1's next I should point to head 2. Head 1's next I should point to head 2. But before that, please keep track of head 1. So okay, I have keep track of head 1's next, which is at temp. This is head 1's next. So that I can simply move my head 1's to the next. Now my head 1 is here. But still, your head 2's next should point into head 1. This is what I wanted, but with that I might end up forgetting this loop, because I might end up forgetting this. So I should keep track of this temp in the temp 2. So I'll keep in the temp itself, because temp I have already used, so I can use the same temp again, and I'll say okay, this is my temp right now, temp. So head 2 next will become head 1. Okay, great. Now let's move your temp, which is this is your head 2. Now again repeat, loop the same process. So I'll just simply use a while loop. Loop it again. Head 1's next will again become a head 2. Head 1 will move next, which is this point. My head 1 will move, and same head 2's next will become head 1. Okay, head 2's next, although it is already there, but still, okay, head 2's next will become head 1, and again move your head 2 to the next. Okay, head 2 has moved here. Same, you can see head 2's next is null, so you can simply stop right here. So this will actually suffice. Head 2's next is null. You can simply stop at that point, and that's the only code you have to do. Again, the code is exactly same as that of Palindrome also. While again, firstly, you will get the slow and fast pointers so as to know the slow. Slow is the middle of the linked list. Then the slow pointer is actually your Q pointer, so that you can reverse that part of the linked list from there itself. Exactly same code as that of Palindrome also, which means as that of reverse the linked list. Now comes the changed part of the code. As I showed you, I will take a head 1, which is the very head, and head 2 is the P. P is the reversed linked list head. So head 1 is there, head 2 is here. I will simply keep on moving while my head 2's next is not equal to null. That I figured out. See, this thing I figured out by making the diagram. Not, although for you can figure out with the mind also, but that I made out with the diagram itself. Now, I firstly said that generate the temp pointer, and then head 1's next will become head 2. Head 1's next will become head 2. As I'm making head 1's next to head 2, so I should keep track what was the head 1's next originally, because I have to move my head 1 to that next pointer of him, because head 1 should move like this, head 2 should move like this. So I should be knowing how they have to move. So this is, I'm keeping track of head 1 and pointing head 1's next to head 2. Same head 2 next to head 1. But still, I should keep track of what was the temp pointer. Head 2's next. And then ultimately head 2 will move, head 1 will move. I can simply keep on stopping while my head 2's next is not equal to null. And that is how I can simply solve. Now I have merged both the linked list. And again, the time is over fine, space is over fun, because of we use most optimal approach both to find the middle of the linked list. We use the most optimal approach to reverse the linked list, and we use the most optimal approach to merge the two linked lists. That is the reason we achieved it in O of n time. So in this video, you learned 4 most important questions of linked list, and that's how it can help. That's how it can actually help you in the in interviews and exams. Cool. Again, it is also exams itself in the college exams. Cool. Bye bye. Take care. I hope that you guys covered the yesterday's question also. I was trying to bring the video, but I was like, I had to go work, but then I was so like, I just passed out yesterday. But bye, take care.